Welcome to our webinar series on linear technology. This first video kicks off a series of exciting content covering the key components, functions, and applications in the field of linear technology. If you haven't had much exposure to the topic so far, you're in the right place. We'll guide you step by step, explaining everything in an understandable and practical way. To start, we'll take a look at the fundamentals of linear technology. What is it and where is it used? We'll clarify exactly what a linear guide is and discuss the differences between rolling guides and sliding guides. Plus, we'll explore various components. We're glad to have you here. Let's dive right into our first question. What exactly is linear technology? Linear technology is an important subfield of drive technology and involves mechanical and mechatronic systems that enable precise linear movements. It's characterized by low friction resistance, high repeatability, and reliable performance. Additionally, it can handle radial loads without significant deformation. Key components include monorail guidance systems, shaft guidance systems, linear drives like ball screw and belt drives, as well as complete linear systems. Before we dive into the individual components, let's first answer the basic question: what exactly is a linear guide? A linear guide ensures that components move along a straight line, precisely with low friction and in a controlled manner. It consists of two main elements: a fixed guiding part, like a rail or shaft, and one or more moving elements, like carriages or ball bushings. These elements allow other components in the system to move precisely along the desired path. Linear guides are crucial in many industrial applications. Linear guides come in two types: rolling guides and sliding guides. Let's take a look at what sets them apart. Rolling guides use balls, rollers, or needles that move along a guideway. This has a major advantage. Friction is extremely low, which makes the movement not only very smooth, but also highly efficient. Rolling guides also provide high guiding accuracy and load capacity, making them ideal for precise applications. It's important to note that rolling guides require regular lubrication and maintenance to continue functioning reliably. Sliding guides, on the other hand, don't use rolling elements at all. Instead, they rely on solid sliding surfaces, which leads to higher friction, but also makes them more robust, lower maintenance, and better suited for harsh conditions or dry running. Linear technology is used in a wide variety of fields. In building technology, for example, it enables the operation of sliding doors, windows, or ventilation flaps. In mechanical engineering, it ensures precise feet and positioning movements. Today, it's also indispensable in automated storage systems and assembly systems. Additionally, linear motors are used in transportation systems like high-speed trains or modern subway systems, as well as in 3D printers and CNC machines. Before we dive deeper into the workings of linear technology in the upcoming webinars, let's take a quick look at some key components involved in generating linear movements. Let's start with shaft guidance systems. These allow unlimited longitudinal movements and consist of a shaft along with one or more linear ball bearings or linear plane bearings. These systems have proven reliable in many industrial applications. Monorail guidance systems provide precise, low friction, and quiet movement. They consist of guideways and carriages, where rolling elements like balls or rollers move along the tracks. There's also a version without rolling elements, a sliding guide, which is ideal for low-maintenance applications. Track roller guidance systems combine aluminum carriages with track rollers and a guideway with one or two integrated shafts to enable precise movements at high speed. This type of guide is especially suitable for harsh environments and long travel distances with lower maintenance needs. Ball screw drives consist of a threaded spindle, a nut, and bearing units that work together to produce precise linear movements. These drives are particularly suited for applications where high accuracy and repeatability are required. Finally, let's look at belt drives. These transfer movement and force via tooth belts that engage with sprockets. Belt drives are ideal for high-speed, precise applications and are known for their low wear. In the next webinar, we'll focus on shaft guidance systems. We'll explore their properties, explain how they work, and showcase different designs. It's a great opportunity to deepen your technical knowledge further. We hope you'll join us again. Thank you for your attention.